failure. So that's essentially what an array is, and a matrix is an array of arrays. For instance, we would do, let's say, benchmarks. Would be the name of this, benchmarks. Marks. Okay, and then what you do is, to define these, is you actually use a double, it's essentially two arrays stacked together. So you essentially define them the same way you would with the normal array, going horizontally. And then we would just add this into here too, but since this is going to be this is a string array, we're going to have to do something a little more interesting. If you remember earlier this morning, I mentioned something about changing variable data types. I called it casting. Well, that's what we're going to have to do here. We're going to have to cast these values from strings into integers, or rather floats. Well, we'll do integers just because, well, let's see, I don't know, let's go find the code to change it to a float. Cast string to floats plus C++. Google is your friend when you're a programmer, as long as you know the correct, A2F, okay, so A-toy is the one for string to int, so atof, I guess, is going to be the one for float, which I guess makes sense. A2I, A for whatever, but 2 floats, 2 int. So I guess we could do it that way. So now we can get rid of, well, essentially now what happens is that we actually have a more complicated process here. So what we want to do is change this to benchmarks. However, we have this. Then we need to close that off with a and then we need to add in benchmarks again. Now, so since arrays are essentially, or matrices are essentially two arrays put together, two or more, well, yeah, two arrays put together. What happens is that okay, wait, I think it's columns, rows. I wrote this down somewhere. Matrices are defined a little differently in this, so ignore what I have there right now. That's not how you define it. That would be for 9 arrays of 9 elements. We want 2 arrays of 9 elements instead. So I need to figure out, I think I have it written down in this book in chapter 4. It's always something that kind of slips my mind about which particular array bracket is the one to use. Essay questions. No, we don't need that. I need a thing about arrays. Some vectors. Sample program, allocating memory, deleting memory, dynamic memory, returning multiple return values, passing arrays to functions, and we're getting closer to pointer arithmetic. Arrays revisited, dereferencing, pointer initialization. Maybe it's in chapter 2. Okay, here we go, yeah, multi-dimensional arrays. Let's see, so, for loop, multi-dimensional arrays, aka matrices. Now I have it written down somewhere. It's the good thing about owning your own textbooks is that you can write down in them. I've got a whole bunch of notes in different sections about certain things. So there's arrays. It's going to be somewhere in here. Where did I put it at? Oh, here we go. No, never mind. That's for 4 arrays. Where the hell did I put it at? Linear search. Oh, here we go. Alright, so the first set of brackets on matrices is for how many columns you want, and the second is for how many rows. So again, columns is the number of elements and rows is the number of arrays. So we want 9 and 2. Or, I actually have it backwards on here. Actually, no, I read it backwards. My 2 looks like a 1. My writing is the quality of doctor's stuff. So you actually want 2. The number of rows is first, the number of columns is second. So 2 and 9. There we go. Okay. So 2 and 9. So you have 2 arrays of 9 elements each. And the way you do this in a for loop is you use a nested for loop, or a for loop within a for loop. So what happens is that you, the first one here is only going to be for the game name. So we want to lock it onto element 0, which would be element 0 is going to be array 0. So element 0 and the element within the side of that element is going to be I. So in other words, we're going to stick, this is going to be stuck to the first array, and then the second section says that you're going to go through each element of that array. Now what you do is you put another for loop in here. For int j, or some other letter, it doesn't have to be j. And again, j is less than or equal to, or less than size of benchmarks. Of course, you also have to use the size of property here. And now here's where it's going to get a little interesting. We'll need to create, let's see, storage variables. So string data equals blank, and then float data2 equals 0.0f. And I'll see what we'll need does in a second. Then -1, and then j++. Now for this one, we want to first grab the element value. So we want to go and store that in data. So we want to go data equals benchmarks. In this case, we want to go 1, since we're going to be stuck on the second array, and then j for this one here. I suppose you could still use I if you wanted to, though. Phone's ringing. Let's see who's calling. Not that important. I'll let the machine take it. Let's see. So, you have that. Now, what we have to do is say data2 equals, and you're going to say a2 F, and then I think it's going to be C underscore str, no, data, then dot C underscore str, and there. And then you're going to print out count data 2. And also do an endl. I'll do this on this last one, I'll put that there, so in case it starts, in case it's going to go batshit crazy again, we'll be able to see what's going on with it. So, we'll go ahead and build it. Conversion from double to float. Possible loss. Let's see, line 8. Oh. We need to close off this for loop. I forgot to do that. Alright, that should fix that. Alright, so now, 29. Really, that's interesting. Anyway, let's go ahead and rebuild it. Succeeded. Alright, we'll go ahead and run it. Alright, we need to do the debugging. That's right. And again, it's still being stupid like that. So Battlefield 3. And once we pass that count, we'll see. Oops, let's go over here. And there you have it. There's the value there. Oh, damn. Ha! There's something I forgot to anticipate. Stop debugging. What you want to do is not do this. But we want to, at the end of this, then say continue, I think. Which will break out of that loop and back into this one. Let's try that again. Yes. Alright, it's Battlefield 3. No. Damn it. Let's see. Let's try break. I'm not sure. I haven't had to do this, use it this way before, so I'm not too sure on the syntax, if break is correct or not. Yeah, there we go. There we go, that is it. So here we go, Battlefield 3. Of course, there's no space. My mistake there. Again, you learn as you test your program, you'll figure out that you need to add things in certain places. Or better yet, let's just use that separation thing we used before. Alright, here we go. Now we should get a proper looking thing here. F5. So yes, there you go. And that's how you use a matrix. That's interesting. Just continued on without actually breaking. As if the conditional statement was never true. Maybe I have it set up wrong then. Let's see. Let's go back over to, let's find a for loop that I know works for sure. Let's see, where would be a for loop in this? Tech merchant. I know I have some for loops there that work. Blah 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 blah. Control entities 4. Well, there aren't any here. Maybe it's on. Maybe that's handled somewhere else then. Let's try player. Display status, ship status, battle, pillage, ship battle, ship pillaging, ship battle. Oh, here. This is it. There should be some for loops here somewhere. There we go. So, yeah, so while I is less than stripe lines. I know that works, so that should be what it should be on the other program. So it's not that it's not being triggered because of how it's set up. There's something else wrong with it. While I is less than size of benchmarks minus 1. Then again, we are doing 2 benchmarks, or 2 arrays. Well, let's take that out entirely and just say, well, I is less than 3. Since we only have 2 there. Or no, less than 9. Or I guess in this case, yeah, 9, because it's 0 to 8. And let's run it from there, see what happens. Let's see, 5. Really? That's interesting. So was how I was using the arrays to do that. That is very interesting. So that used to work properly. I don't know why it's not now. Stop debugging. Let's go to release and run it. Nah, it's working now. That's weird. Used to be able to use arrays like that. I'm not sure why you can't now. Hopefully somebody will reply to that and tell me what the hell I did wrong with it. But there you go. That's how matrices work. How you can use them to store information and pull that information out of the matrix. And also how you cast data as well with this. And also how you use the for loop. So there's a couple different topics there that we covered. So now that we've gotten through matrices and arrays and all that stuff, or at least the basics of those, let's move on to inheritance. Class inheritance is really as it sounds. You have a base class, and that has the values and stuff you want to use for another class, but you also want to have special attributes for the child class that the parent class does not have. And that's what's known as inheritance. The child class inherits the stuff that's in the parent class, but also has its own attributes as well. So we're going to make another project. I'm going to go ahead and do another, let's call this one inheritance. Inheritance, I don't know. I think that's spelled right, but if not, who cares? I don't at the moment. Empty project. Set that as the startup. And let's go ahead and close all this out. I won't be needing it. So, in this one we're going to be creating a small program here. It's actually going to mimic a Java program I wrote for a class back in my associate's degree. So new item, main, CPP file. We're also going to have a monster class. I'm going to go to the header, add new header file, monster. And I'm also going to show how you can actually use these header classes for more than just one class or struct. You can, if you wanted to, put a whole bunch of things, different classes and structures into this one file if you wanted to, but you should only do that if those classes and structures are related to each other, as these ones will be. If there's, a monster and a player class, you shouldn't really mix those two together. Again, that's just more of a organizational thing. But we have to define this one, so f not defined, monster h, define monster h, include string, and that's all we're really going to need for that. So using std string. Okay, so class monster. So let's have a constructor. Actually going to look up one thing real quick here. So public class monster extends JFrame. And this is Java, by the way, in case you're wondering what the hell this is. It's based off of C++, but it's made so that it can work on any operating system. Whereas C++ is exclusively a Windows coding language. So, and this is actually even more complex. This is using GUI programming. Actually, I want to just choose a less complex version of that. How about this one? Just trying to figure out something really quick here. Extends monster. Okay, so it does have its own constructor. Alright. Go ahead and close that then. So we'll do monster constructor here. So now we're going to do void set name and pass string name, void set race, string race, void set health, string or int HP, and void set strength, int str. Okay, and then we'll do just need to put those as public. One more thing I need to look up really quick here is if I need to make that particular no, okay, that's defined in the child class. Here's an example of inheritance here in the actual Space Crusade program. but I'll get more into that a little bit later, or way later on when we get to that part of it. Now we need to have the get functions. String get name, string get race, string or int get health, and int get strength. Alright, then private string name string mrace, string or int health, int strength. Alright, and that does it for that class. End if. Now, or rather, wait, we need to save that for after the second one here. So now we're going to create a child class of that class. So class baby monster, public monster. So now what this does is it tells the program essentially that baby monster is a child class of monster, and so it inherits all this stuff here. I mean, not the constructor, but all this other stuff here. Now let's say though that we want to have a few different things for this. Here's what we would do with it. So again, we'll do the public baby monster, and we'll actually fill some of that stuff out in a second here. Since we already have all this stuff, we don't need to worry. But we're going to add something to something different to one of these different functions here. Actually, let's do this. Let's leave this out. We're going to put that stuff inside of the constructor. Trying to figure out a way to do this to show you function overriding or inheritance overriding or whatever the hell it's called. Trying to show you how you can override a parent function in a child class with different elements. Or with different overrides and stuff like that. Where could we do it at, though? It's gonna have to be one of these. Well, anyway, I'll do two examples. We'll do string get name, and this will override the get name function from the other one. So I guess we'll do it that way. And that's all we'll have to do for that. So that is a full class. And we'll have access to that stuff, as you'll see here in a bit. What we'll need to do with this now, though, is put in a string name, string race, int health, and int str. And then we'll do the same for this one down here. Alright, so now we go to well, I'm going to try something first. We'll leave that there for now, but I also want to try something else as well. But for here, we need to go include IOStream, include string, include monster.h, and using namespace std. So first thing we need to do is do the monster class stuff. So monster, string name, string race, int health, int str, and m name equals name, m race equals race, m health equals health, and m strength equals str. There's the constructor for that. Then we need to do the get functions. Return name. String monster get race, return race, mrace rather, int monster get health, return m health, and int monster get strength, return m strength. Now for the baby class, we go baby monster, and we can just use these exact same things here because it uses the exact same stuff. No default constructor for class monster. Oh. Well, now there is. Okay, that fixed it. Monster name, end name, inaccessible. That's interesting. It's supposed to inherit that stuff. Let's check back over here. Weapon.cpp. What is one of the, let's see, weapon accuracy? Weapon name. Let's say, so. Very interesting. Let's head back over to here. Look at this class. Okay, so no, yeah, the class only inherits anything that is defined as public. So that's my mistake. If the attributes are not declared public, it won't inherit them. So perhaps we could do it as protected. That'd be a more realistic way of doing those for the monster class. And now we have the get name is different. This a string baby monster get name. What we're going to do now is we're going to say return baby plus m name. Alright, let's go ahead and create the main section here. Actually, we won't need IO stream on this one. Go and get rid of that there. So, we will need it here though. So, include IO stream. Include string. Well, yeah. We will need that as well. Include con.io. Then include monster.h. So now we're going to go ahead and create a couple monster classes. A couple instances of these monster classes. So first off, we're going to say monster. Then we're going to say, let's say rabbit equals monster. Then we need a name, so rabbit. A class, beast. Health, say 15, and strength 4. And what this does, it creates a monster class named rabbit. And you can use rabbit to to access the class as a reference. So now we're going to create a baby monster class for rabbit. So baby monster rabbit equals baby monster rabbit beast 6 health with a strength of 2. There's the baby monster class. And then we'll also do another one. Monster bear equals monster bear beast 25 and 10. And baby monster bear equals baby monster. Let's use 2 just in case there's just going to be a naming conflict. Bear beast 12 and let's say 5. Alright, so we have 2 monster classes here. And now we want to print these monster classes and show how the baby monster class overrides the getName function for the monster class. So we'll do count monster name space bear, or we'll say rabbit first, dot get name. Count monster race rabbit dot get race, and L Alright, and then all we have to do is copy paste this 3 more times for each monster, and just change the change this part to suit what we need. So in this case we just need to go to 2, change this, and then we change this to bear from rabbit. We can just do that easily by using the quick replace function. Search for rabbit and replace with bear. Replace all in the selection, and all you have to do now is add the 2's to the second one, and you're done. So now we need to just close off the main and add the get ch, and let's go ahead and build it. Now we got an error, so let's see where it's at. Inheritance, you see, let's see, specified link. Where's my error thing at? It's not showing up on this window. View error list. There we go. Error mt.exe exited with code 31. What the hell? Very strange. mt.exe code 31. Well, let's copy this, open a new one, grab this error message, and go see what the hell it's about. Generate manifest. That's interesting. Underneath project or actual? Okay, so it's per project. So properties, it's going to be underneath, or actually no, per project itself, not solution. Properties, linker. Let's see. Manifest tool, verbose. Linker manifest file. Ah, there. No. Alright. Actually, we probably want to go with the verbose. We'll leave that there. Okay, so now let's go ahead and build it again. And succeeded. Alright. We'll head back over to release. Should be a new file there. And here you go. And let's fix that issue right now. Space. Control save, build, and rerun it. Alright, so here you can see how it's how you can overload a parent member or a parent class function to do something else for a child class. In the parent class, it only printed out the the actual name, but in the baby class, it adds baby to the beginning of it by overwriting the original parent class's function and using its own. So that's kind of a small crash course in inheritance, and also in creating instances of classes as well. There's even the more complex level where you create an array of class instances. And I'll show you an example of that in the Space Crusade code when we get to it. Well, actually, really, I think with all this having been covered, I think you're probably sufficiently so you got plenty of space, sufficiently ready to see some of the code. Let's go ahead and switch over to that then. Let's see, I just want to check this real quick, see if any responses have been counted. That's interesting. Really? That's very interesting. Well, let's actually just copy paste the data back over. So that's interesting. Oops, it's not the startup project. Now it is. No, it still errors out. Errors out like a mofo. Let's see. Size of, get names. Let's see. Count of, or equivalently size of games. Oh, I see. Divided by size of games. 0. Helps to read the entire statement, I guess. Ah, there we go. Yeah, now it works. I think the size of works differently in Java. I think that's maybe where I picked that up from, was my Java classes. Count of, though, that's interesting. Count of. For game names. I'm saying it's undeclared. Maybe you have to add something in. Underscore count of. stdlib. I see. So there was a required header. So if we add that in, include stdlib.h. -1. And that works too, there we go. Alright, so that problem was figured out. That's another thing when you're a programmer, never be afraid to ask questions like that. Do I have, let's see. That's from, just want to check this real quick. This was an interesting kind of problem I had. I found out that you can install Visual Studio over multiple hard drives. It has to be installed all onto the same hard drive, or else it just goes completely crazy and won't even really compile anything. Got more phone calls. Sorry, this call I had to take. I actually stopped the recording there for a bit. But as I was saying, actually, what was I saying? Actually, I'd finished what I was talking about with that stupid piece of crap thing. Go ahead and close these. Only the first one's uploaded so far. That kind of sucks. Anyway, so let's go ahead and take a look at Space Crusade's code. Let me open up the changelog real quick here so I can remember what I did so far this month. Yeah. I'll be doing a little more work in the next week on this too, because I haven't really been doing enough work on it for my liking for this month. So yeah, start on August 17th. Pretty much all this month, the work has been done mainly on kind of cleaning up stuff from changes made from last month, and working on the station menu stuff as well, or station class stuff as well. Let's see. Let's go to station. Well, let's go and just kind of walk you through a little bit of what's going on here. Whoops. So here we have the main file here. Got all these different references to create access to functions and stuff. This is the title menu and the game loop, which is pretty sparsely populated right now. Most of the work, and I'll show you the data system. Crap, I keep on double clicking, don't have to do that. So here's the way I'm doing, instead of having everything hard coded like it was in the previous version, this is how we're doing it now, with a matrix of essentially it's an item database, if you will, or ship and item database. Essentially you just put all the information for each ship into an array, and then you can just call up that array from the matrix whenever you need it. All the weapons. $125 weapons so far. We've also got I started on doing the missions stuff as well. There'll be a lot more of these in the final version, or as I continue with it, I'll be making more of these. What these just do is create missions in the bounty office that you can take for resources and increased fame and stuff like that. And planet names, diplomacy positions, races, and ranks. And we have all the different code to access all that information. Again, as you can see, we're doing a toy, so we're converting the string into int data. And here's one thing I didn't mention, is that you can actually also do it this way on these, when you return these, when you get the data from strings, and or data from arrays. In these array brackets, you can actually do math inside of those as well. So in this case, we're passing the item code, which is going to be 1 to whatever number. But since everything in the array starts on 0, it's actually going to be 1 less than whatever the number passed to the function was. So, and this way we're taking the weapon code, subtracting it by 1 to get the actual item code, item database number for that weapon. That's something I added just recently, as well as this part. This used to happen in a different, in the player class or weapon class or ship class. So I moved all this over to here and was able to delete a lot of lines out of those other classes, thereby simplifying them. You can also use the return style, like this style of function where it returns a value with bools. That's something I didn't show you before. I will now, though. Player CPP, looking for Actually, no, ship. Everything's done with ship as regards to that. Since the player isn't actually going to get killed, it's the ship that's going to be destroyed. I changed that from being in the player to being in the ship, and you just access it from the ship class, or the ship reference in the player class. Is ship destroyed? Yeah, is ship destroyed? And you can return a true or false value based on a conditional statement. So if hull is less than or equal to 0, return true. If it's not, return false. In that case, that's telling the game if the ship has been destroyed. If the ship's hull is at 0, it means the ship is destroyed, to indicate that the ship is destroyed. Which means that either the enemy ship is destroyed or the player ship is destroyed. They both use the ship class. Then we also have disabled for some of the different special damage types. For instance, if you shoot a EMP missile at the enemy and disables their ship, it will trip this status, and the enemy won't be able to do anything for a set number of turns. That's something new added into this version, wasn't in the previous version. Same with the shields. You can disable the shields then in that way as well, and you can also do it with a virus weapon as well. Both of those, you can disable the ship and the shields with a virus weapon. Here's the ship setup code. Again, here we used to have a lot more code where we would cast the string data to int data if it needed to be, but that created like it was like all the way down like 60 lines or something of code, and we shrunk that down to being just 28, or rather not 28. Let's see, where's this? Our columns is the one we're looking at here. 33 lines of data of code, as opposed to all that other stuff. Same with this one here. This used to have a whole bunch more code as well, as did this. This sets up the hostile resource information, and also the value, the expense that the ship is when you buy it. Or rather, we probably actually don't need those now that I think about it. It's only going to be needed for hostiles when you pick up that stuff, so I'm just going to go ahead and not delete it. But I'm going to use a block comment, which is done with a / asterisk backslash to close it off. And that essentially just will comment out any text, anything in between those two things. These are good for when you're at the beginning of the file to make a long description about the file's about, or to do this, so you don't have to put two / in front of all these lines. And that that calls the initialize hardpoints function up here. And this is kind of where you can see an array of classes. It is with these here. If you go to ship.h, I think it's open. Might be hidden away somewhere. No, I guess it's not open. Well, we'll open it then. If you go to ship.h, you can see that we have strings of classes here. So beholds is an array, an array of classes, is an array of bomb classes. There's 8 of them. And just as HW bays is an array of heavy weapons, laser banks, an array of lasers, M turrets, array of missile classes, and R mounts, an array of rail classes. And what you have to do then is you have to initialize these elements before you can use them. And that's what this does over here. These for loops will look at the number of missile turret points on the ship, and as long as I is less than or equal to that number, it will iterate through that array and initialize the hardpoints. And it will only initialize the hardpoints that are the number of hardpoints the ship has. So there's a max of 8 hardpoints at the moment. It'll actually go up for Titans and stuff like that. They'll have a lot more hardpoints than that. But it'll do it to the specific number of hardpoints that that particular ship has. And then after that, you go into the weapon class to initialize the values for those as well. That doesn't happen until a little bit later, I think. Let's see. What else can we go over here before I actually start doing some code? Battle processing, let's do that one. Here's an example of what I was mentioning earlier with having a block of text describing something commented out with those block comments. I don't know, I guess you call them characters. But this is where all the battle happens. The battling stuff is going to happen. Before it used to happen in the actual particular class that was fighting at the moment, but I decided to move it to a more central location and just put calls to the functions in those classes for handling damage. But the actual battle will happen in here. And again, here you can see that whole array of classes playing out here with hostile and player team. For the player array, that's more for when I implement wingmen for the player. And then also for the hostile teams for multi-ship battles. Again, using switches and while loops for all this stuff. Forgot to put the break in here. Alright, no I didn't. That's an if for that. Never mind. Let's see. And if statements to determine, like for instance, here's an example of how you kind of have to anticipate stuff. So basically what this for statement is saying is if the player ship's initiative is a higher value than the current enemy, than the hostile team enemy ship is, then, and if P is attacked and P has not escaped, then the hostile team gets to attack. And what these ampersands mean is an and kind of thing. Just as the double, these double things here meant or, these mean and. But with these ampersand operators, you have to use a different style of if statements. You have to use a what I call double nested if statement. In other words, an if statement that encompasses several if statements, instead of an if statement that contains several or statements. And that may seem confusing and it may not actually be technically correct, but that's how I view it as. So, in other words, this here is an if statement by itself. And this is an if statement, and this is an if statement. So if this is true, and if player attacked is true, and if escaped is false, only then do you go with this. But if it was or, it's if this is true, or if this is true, or if this is false, then do this. And in my mind, that since you don't have to do this double nested if statement thing, that makes it one entire if statement instead of double nested, or however many this is. I guess triple nested in this case. So consider yourselves thoroughly confused, or at least I expect you to be from that explanation. But again, then down here is another example of it. In this case, though, we are positing the possibility of the hostile team attacking first. And that's only if the enemy ships have a hostile disposition and their initiative is higher than the players for that particular ship. Which really, if they're on the enemy team, all ships are going to be hostile, so I might have to figure out a different way to do that. So let's go ahead and get to writing some little bit of code here before I have to get off. Let me check the space. 55.5 gigabytes left. I'll actually save that for the last segment of this first developer's vlog. Just keep everything kind of fit in together where it should go. So this is J-Well signing off. I hope you found this segment of our developer vlog to be as informational as the first one, if not more confusing. And we'll see you next time.